We are continuing again the magnetic effect of current, the another part. As I have told you earlier, magnetic effect is related to the current passing in a conductor and we will feel magnetism. Now, there are certain examples based on force and torque on current carrying loop. You will always remember that the units of force are generally Newton, dynes, gram weights, and kilogram weights. Torque, that is represented by tau, that is force into perpendicular distance. Now, example number 1. If I current is flowing in wire PQR, it is given the shape according to figure and kept in magnetic field B. If PQ is equal to L and PQR is 45 degrees, then ratio of the force on QR and PQ is given as force on QR over force on PQ. That is BIL sine 90 divided by BI into L under root 2 sine 45. Sine 45 can be taken as 1 over root 2. After calculation, it becomes 1. Now you can see the diagram. That is, B is magnetic field, I is the current in the wire, and angle is 45 degrees. Then PQ is making 90 degrees with B, whereas QR is making PQR is 45 and QR is making 40 degrees with B. Now, second example, the length of solenoid is 0.4 meter and the number of turns, it is 500. A current of 3 amperes is flowing in it in a small coil of radius 0.01 meter and the number of turns 10. A current of 0.4 amperes is flowing. The torque necessary to keep the axis of coil perpendicular to the axis of solenoid will be. Now, solution is given as follows. That is, magnetic field in the solenoid is mu naught NS IS. NS stands for the number of turns in solenoid. IS stands for current flowing in the solenoid. This can be further elaborated as mu naught NS IS divided by LS, or tau is equal to BS into I and A. And after putting all the values and making the calculations, the value of torque comes to be 5.92 into 10 to the power minus 6 Newton meter. However, you will remember that Newton meter means joule. So tau is basically can be expressed in joule or it is in Newton meters. The third example is the effective radius of the coil of 100 turns is 0.05 meter and the current of 0.1 ampere is flowing in it. The work required to turn this coil in an external magnetic field of 1.5 Tesla through 180 degrees will be if initially the plane of the coil is normal to magnetic field. Work done is 2 MB, where M is magnetic moment, B is magnetic induction or magnetic field strength. Compute the value, 2 remains as it is, M that is taken as pi I and B is taken as Na square B. And by computing the values, the result comes to be approximately 0.236 joules. Now, in the fourth example, the magnetic force on segment PQ due to current of 5 ampere flowing in it, if it is placed in magnetic field of 0.25 Tesla, will be. Solution is force is equal to BIL sine theta. Compute the values and the result comes to be 0.3125 sine 65. And we can check the value of sine 65 from the log tables. You can check up the figure. The figure is shown. B is the direction of magnetic field. And similarly, we are finding that angle between PQ and QR is 115 degrees. It means that if we join DQ, then angle made by PQ with CD line or DQ line will be 65 degrees. Motion of charged particle in magnetic field. Regarding this, you must remember that whenever any charged particle is projected perpendicular to the field, it starts moving in uniform circular motion under the influence of some balanced forces. One is magnetic field force and other is centrifugal force. If particle of charge q moves in magnetic field with velocity v, then the force acting on the particle will be bqv, or q into the cross product of v and b. In the scalar form, it should be f is equal to qv sine theta, where theta is the angle between magnetic field and the vector velocity v. Now you can check up the figure. X, y and z are the three dimensions shown, and v sine theta is the component on x-axis, force on z-axis, and q is the charge. Magnetic field is shown by b. Theta is the angle made by y-axis with velocity component. If theta is 0, that is the charged particle moves in the direction of magnetic field, then sine theta is 0 and the force qvb sine theta or qvb sine 0 will be 0. Thus, no force will act on the particle. In this case, the particle will remain in motion without any deflection and the energy and momentum of the particle will remain constant. However, force is 0, but energy and momentum that will remain constant. Again, to review, the figure is shown. If theta is 90, the charged particle moves in a direction normal to magnetic field, then F is equal to qvb sine 90, that is equal to qvb, and this force will be maximum. Force will act on the direction perpendicular to the motion of particle. Particle will move in circular motion. Whenever particle will move in circular motion, centripetal force will come into action, that is mv square by r. The kinetic energy of particle will remain constant. Again, look at the figure as I have described earlier. Now, the next part is that the magnitude of momentum of the particle will remain constant, but its direction will change continuously during moving in a circle. And that direction is indicated by drawing a tangent. If r is the radius of circular path of the particle, then mv square over r is qvb. This type of principle is adopted in cyclotron, which is used for accelerating the positively charged particles. R is mv over qb, that is the radius of the path. mv is replaced by p, where p is momentum. So r is directly proportional to momentum, where q and b must be constant, and r is inversely proportional to b, where p and q must be constant. Again, you can check up the figure. Now, kinetic energy of the particle is half mv square. By computing the values, we will get the function as r square, q square, b square over 2m. If E is the energy of particle, then radius of circular path will be given as r is equal to under root 2me divided by qb. The work done by the charged particle in completing a full circle will be 0. See the figure. Period of particle t is given by 2 pi m over qb, because time period is generally distance over speed. So distance can be replaced by 2 pi r and speed, that is v. We can compute the values and the final solution will become 2 pi m over qb. Frequency n will be 1 over t. So frequency will be inverse of t, that is qb over 2 pi m. The period or the frequency does not depend upon the speed of the particle. As the speed of the particle increases, the radius of the circular path increases in the same ratio, so that the time taken in completing a full circle remains same. This frequency for electron is called cyclotron frequency. This figure is repeated again and again in order to give you an idea that what is the direction of force, the x-axis, the y-axis, and the component v sine theta. When velocity v of moving charge q naught is not perpendicular to magnetic field, that is 0, less than theta, less than 90, then the velocity component v cos theta parallel to magnetic field remains unaffected. As a result, particle moves in forward direction, and due to velocity component v sine theta normal to magnetic field, the particle moves in circular path. Thus, the particle has both types of motion simultaneously, so the resultant motion is in the form of helix. So, helix is shown in the adjoining figure, and v sine theta is one component, v cos theta is another component. These two components are called the rectangular components. So, helix is just like a coil turning. Moving charge particle produces both electric and magnetic fields. If proton and alpha particle having same kinetic energies move perpendicular to the magnetic field B, then ratio of radii of their paths will be. Now, radius for proton, that is given by function under root 2 mpe divided by qp over b. mp stands for mass of a proton, qp stands for charge of proton, E is electric field and B is magnetic field. You will further remember that electric field is given in newtons per coulomb or volts per meter, where B is taken as Tesla. And R alpha can be similarly given as 2 m alpha E divided by Q alpha B, and 2 m alpha E is under the root. M alpha is the mass of alpha particle and Q alpha is the charge of alpha particle. You will remember that the charge of alpha particle is double that of proton and mass is 4 times the mass of proton. Computing all these values, and then when we calculate, the ratio of Rp and R alpha comes as 1:1.